diagram of union of two sets. So as I said, for drawing the Venn diagram, we have to draw a rectangular box where we will be representing the universal set. So this rectangular box is containing the universal set, everything. Okay, universal means everything, all the sets, like everything it contain. And here, if we are having two sets, set A, set B, every set we will represent inside this rectangular box with the help of circles. So suppose we are having a set A and a set B. Then union of like A union B, if we want to represent, then what we understand by union of two sets, we understand that union means everything, whatever is there in A, set A, and there in set B. So we will be shading the portion which contains set A and set B both. So if we have to shade the portion of A union B, then definitely we will shade like this. Whatever elements are there in set A, that will contain this A union B, and whatever is there in B, that also will be there in A union B. And this is the Venn diagram of A union B. Similarly, if we have to draw the Venn diagram of A intersection B, then how we will plot? So same way, first we will be drawing the universal set. Here we will draw set A, set B, and as we understand, like when we have to represent the intersection between set A and set B, it will be the common reason enclosed by set A and set B. Like common reason which is already there in set A and which is also there in set B. So can you see this one is the common reason?
Yes.
Can you see it? So
Yes.
this is the Venn diagram for A intersection B. Now, if we have to draw the Venn diagram of here only, when A intersection B, when there is no common element is in A and B, whenever we are having A intersection B as null set, like nothing is common in between A and B. So that's Venn diagram will be like this. Universal set. Here we will be having set A and here we will be having set B. Here A intersection B means like there is nothing common in between A and B. There is no element which is there in set A and in set B also. That's why we are drawing set A and B completely apart from each other. Like there is a distance between both of them. That means there is no common reason. And this represents A intersection B is equals to 5. This also represents disjoint set. As the name says, disjoint, there is no like common part in between both the sets. Now, if we have to represent in Venn diagram difference of two sets, so if we have to represent A minus B, and if we have to represent it by using Venn diagram, here we will have the universal set. We will be having set A. We will be having set B. And what's the meaning of difference between like A minus B means what? Can you tell me? Yes, Lina. What's the meaning of A minus B? Element of A or B?
Element.
Yeah. Element of element of A which is not there in B, right?
Yes.
Let's say the element of A which is not touched with B. So be careful, just state it which is not there in B. Okay, we cannot take the common part. Element of A, only those element of A which is not there in B. Okay.
Okay.
Now, similarly, if we have to show B minus A, then here element of B which is not there in A. So we will be making the Venn diagram like this only. Universal set, set A, set B, and here we have to shade B which is not there in A. So here we will be shading this part. We are not going inside A. This one is B minus A. Now, if we have to plot complement of A, of set A, then again here we will be drawing the universal set. Here we are having only one and one set, that is A. Okay. We are not talking about set A and set B. We are not talking about A, B, C. There is only one set, that is A. And obviously universal set is there. So complement of A means what? All the element. What's the meaning of complement of set? Yes, Lena. All the element which is there in universal set, but not there in set A, right?
Yes.
All the element which is there in universal set, but not in A. That's the complement of A. So we are going to shade everything which is there in universal set, but we will not touch set A. That represent complement of A. All right. So this one is A complement. Similarly, if complement of B is there, so if from universal set, exclude B. Whatever is left, that is complement of B. Let's do few problems from here. From the sets, the Venn diagram. So if we are having the first question as represent A union B complement with the help of Venn diagram. So we have to represent this one with the help of Venn diagram. How we start the construction of Venn diagram, how we represent any set with the help of Venn diagram. So here first what we do, we draw the universal set. See carefully. At first we will be drawing anywhere the rectangular box which will represent the universal set. Now we are having A union B. Like set A is there, set B is there. We understand what is the meaning of union. Union means everything whatever is there in A and in B, right?
Yes.
And complement means we have to exclude whatever is looking over here. We have to exclude that from the universal set. We have to just take it out from the universal set, right?
Yes.
So what will be the A union B complement? The Venn diagram will be exclude A union B from the universal set. That is the complement of A union B. So exclude A union B. Everything, whatever is there in the universal set, except this one. So let's shade it. Can you see?
Yes.
I have included, just taken out, just left A union B and have said everything apart from that. That is the complement of A union B. Okay.
Okay.
Is it clear, Lina?
Yes.
Now, if we have to show A complement intersection B complement, same way we will start with the diagram, the Venn diagram, that is universal set. Set A is there, set B is there. Now we will understand what exactly we have to draw here. So A complement means what? A complement means universal set minus A, right?
Yes.
And B complement means what? Universal set minus B. An intersection of this one and this one means the common reason in between these two, right?
Yes.
So universal set minus A will be, let me say it. This will be universal set again. Minus A means we are not going to shade A, right? This much only we
Yes.
will set. And universal set minus B means not B. Okay. So we will be shading in the same way. An intersection of both means whatever we have shaded, that is the intersection of both, right?
Yes.
So we got A complement intersection B complement. Is it clear?
Yes.
Similarly, if we are having A intersection B and whole complement, that means we are having universal set. Here we are having set A and here we are having set B. A intersection B means the common reason. Let me mark it. This is A intersection B. And A intersection B complement means what? Everything from the universal set except this one, right? So except this red part, everything will be there in A intersection B complement, right?
Yes.
So if we will take blue color and if we will again shade everything like this, everything except the red color part, okay? Everything from the universal set, we are shading everything. That is A intersection B complement. We have not taken the red color part. That is excluded. All right. Similarly, let's do the last one. If we will be having A intersection union B intersection, not intersection, with A complement union B complement. Again, we will start with the same concept. We will first draw the universal set. Here set A will be there and set B will be there. What we have to draw? Complement of A. That means from universal set, we have to exclude A. From universal set, we have to exclude B. Then which portion we will shade? Can you tell me?
The universal set excluding A and B.
Yeah. From the universal set, exclude A, set A. And from the universal set, exclude set B. And union of both. Take the union of both. So again, we will be having, just a second. So we will be having this from the universal set. A is not there. And from the universal set, again, B is not there. And union of both is this one, right?
Yes.
Now there is a law, De Morgan's law. Which says that A union B complement will be equals to A complement intersection B complement, which also says that A intersection B complement is equals to A complement union B complement. Here we can check this law by taking an example. So let's take, we are having an example. Let's say we are having an example, a universal set is there, which is having an element 1, 2, 3, 4, 5, 6, 7, and 8. A set A is there, that is 3, 4, 5. And a set B is there, that is 4, 5, 6. Now, let's check the first law, the first rule, this one. This one, that is A union B complement is equals to A complement intersection B complement. So A union B means what? Can you tell me from the given example what will be the element of A union B?
3, 4, 5, 6.
3, 4, 5, 6. Right. And what will be the element of A union B complement?
1, 2, 7, 8.
1, 2, 3 will not be there, 4 will not be there, 5 will not be there, 6 will not be there, 7 and 8 will be there. So this is A union B complement. On the other hand, we have to find A complement. What is A complement?
1, 2, 6, 7, 8.
1, 2, 6, 7, 8. Perfect. What is B complement?
1, 2, 3, 7, 8.
1, 2, 3, 7, 8. And what is the intersection between A complement and B complement?
1, 2, 7, 8.
1, 2, 7, 8. Can you see? We got exactly same sets. Both side, left hand side answer and right hand side answer is exactly same. Can you see it?
Yes.
So this way we have proved the De Morgan's law. This way we have also checked the De Morgan's law. Okay. So this is what the De Morgan's law says. Now we are having law of double complement. Which says that A complement, and again if you will do complement, you will end up having A only. If you will check with the previous example, you will get the same. So let's check it. A complement already we have found. A complement already we have found, that is 1, 2, 6, 7, 8. And universal set was 1, 2, 3, 4, 5, 6, 7, and 8. So if we will do the complement of this one again, can you tell me what will be the element?
3, 4, 3,
3,
4, 5.
3, 4, 5. That's it. Right?
Yes.
Here, can you see We got exactly same.
Yes.
So A complement, and again if you will do the complement of that, you will end up having A only. Okay,
Yes.
just a second now. Now next one, there is the law of empty set and universal set. And the law says that complement of empty set will be universal set and complement of universal set will be empty set. All right. So if we are excluding complement of null set means what? Null set means nothing. And if you will exclude nothing from the universal set, obviously you will be having universal set, right?
Yes.
And similarly, complement of universal set. So total you are having a universal set. And from that universal set, you are excluding everything, whatever is there in the universal sets. Then what is left? A null set is left, right?
Yes.
So this two rule came from there only. Next one. We are having few examples, or we can say we are going to solve few questions where the sets are given in set builder form. Okay, and we have to find the complement of that. Whenever we are having a defined set in a roster form, like a finite set in roster form, it is very simple to find the complement and to check the element, which element is there, which element is not there. But the confusion creates when we are having the set given in set builder form, and that too infinite set. Okay, so let's do few problem where we are having a universal set as infinite set, the given set as infinite set, and that too in set builder form. So number one is x, set of all x such that x is an even natural number. Here the instruction, let me write first and then we will be doing it. So the instruction is universal set is equals to set of natural numbers. We have to write the complement of the given set. The first number question is given. We have to write the complement of that. Okay, complement of this set. Can you tell me what will be there in the complement of this set?
It will be odd natural numbers.
Exactly. It will be set of all x such that if we will exclude the even number from the natural number, so we will be left with odd number. So x is odd natural numbers. Okay. Let's do the next one. So if we are having number 2, that is x, such that x is a prime number. Again, the universal set is same. Okay. So if we will exclude prime number, again we have to find the complement of the given set. So can you tell me what will be there as a remaining set? Yeah.
It will be square root numbers.
Square root number, prime number if we are excluding. Prime number means numbers which don't have any which are having factors as 1 and itself. Like 13. We cannot factorize 13. So 13 is a prime number. 17. 17, if you will try to factorize it, it is not possible. So 17 is a prime number. It can't be divided by any other number. So what will be the complement of that? So the complement of this will be composite number, right?
Yes.
Like prime number which are not divisible by any other number. Composite number are the remaining number which can be divisible by the other number. So it will be set of all x such that x is a composite number. There are two parts: prime number, composite number. Prime numbers are number which is not divisible by any other number apart from itself. Okay, like 13, 17, 23, these are the numbers which are prime number. No other number can divide it apart. Just 17 can divide 17, 23 can divide 23, right? So rest of the numbers are composite numbers. Apart from that, we are having one which is neither prime nor composite. So we also have to take x equals to 1, because natural number include 1, right?
Yes.
So if we are taking out prime number, if we will exclude prime number, then what is remaining in hand with the set of natural number? So in hand we are having composite number, but we are also having 1. 1 is neither prime nor composite. Got it?
Yes.
Let's do the next one. So the next one is x such that x is a positive multiple of 3. So what will be the complement of this one? If we will exclude positive multiple of 3 from the set of natural number, what will be remaining?
Negative multiples of 3.
No, natural number has only 1, 2, 3, 4, dot, 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 like till infinity. So here we don't have any negative number. Natural number doesn't have any negative number, right?
Yes.
Natural number are the just the counting number which starts from 1. Those are natural number. So if we will exclude the multiple of 3, if we will cut down the multiple of 3 from here, then rest of the numbers are not multiple of 3, right?
Yes.
But don't write negative word, because natural number doesn't have any negative numbers. So it will be x such that x is not positive. Like not positive, no, sorry. It has to be positive because natural numbers are positive. It is not multiple of 3. So all those numbers which are not multiple of 3, that is the complement of the given set. All right.
Yes.
Now the next one. If x such that x is greater than or equals to 7, then what will be the complement of this set? Again, we are having natural number as a universal set, like 1, 2, 3, dot, 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 till infinity.
It, it will be smaller than 7.
Exactly. If all the greater than or equals to 7 number is there, then the remaining will be x such that x is, we can write it directly, x must be smaller than 7. And it has to be natural number. X belongs to natural number also. So no other number which are smaller than 7, like negative numbers, we cannot take. We can only take those natural number which are smaller than 7. Okay, because the smaller than 7 is -1 also. Smaller than 7 is -2 also. It is -3 also. But natural number doesn't contain. negative numbers. Okay.
Yes.
Similarly, if we are having the last one as the set of all x such that x belongs to natural number and twice x plus 1 is greater than 10, then what will be the complement of the given set? Here we know what is the value of x, what is the range of x. Do we know? We don't know. Let's solve it. Twice x is greater than 10 minus 1. Can we do like that, Lina?
Yes.
That means twice x is greater than 9, right?
Yes.
That means x greater than 9 by 2. Now let's see the set. X belongs to natural number and x greater than 9 by 2. So all the remaining number will be the complement. So what will be the remaining number? Can you tell me?
X is equals to smaller than 9 by 2.
Yes, smaller than or equals to 9 by 2. So x belongs to natural number and x must be smaller than or equals to 9 by 2. Here we are defining it that it must be a natural number. That means we are not taking any decimals. We are not taking any other number, right?
Yes.
So this is the complement. This is how we will find the complement if the universal set is given like that. If the universal set is infinite set. Now few rules are there, and on the basis of those rules, few word problems are there. So the rules are, let's see the rules quickly, and then we will be solving, then we will solve few word problems related to that. So the rules are, if A and B be finite sets, and if A intersection B is equals to 5, that is nothing common, like there is no element common in set A and set B, nothing common in A and B. So the rule says that number of element in A union B will be just the addition of number of element in A and number of element in B. This is when we will apply this, when there is nothing common in A and B. Set A is there having 4 elements, set B is there having 5 elements. The number of element in A and B will be just the addition of these two. All right. Now the next rule says that in general, that means if there is common term, okay, if there is common element, if there is common object in set A and B, then the rule will be different. All right. So in general, if A and B are not disjoint, A and B are not disjoint means there is something common. There can be something common. Okay. Can you hear me?
Yes.
Yes, Lena. Okay.
Yes.
If these two sets are not disjoint, then A number of element in A intersect union B will be number of element in A plus number of element in B minus number of element in A intersection B. If there is something common, then you are taking number of element of A, you are adding number of element of B, and if already something is common, then that means you have taken it twice, right? That's why we have
Yes.
to subtract it once. Are you getting it?
Yes.
We can understand it like this. If there is a set A, if there is a set B, here we are having 1, 2, 3, here 4, here we are having 6, 8. So how many elements are there in A? Can you tell me?
3.
Only 3?
No, 4. 4.
Exactly 4. And how many elements are there in set B?
3.
3. Okay. So when you have to find number of element in A union B, then what we have to do? We have to take the number of element in A, that is 4, number of element in B, that is 3, and then you have to do the subtraction, because if you will not do the subtraction, then how many element we are getting? 4 plus 3 is 7. Let's count total 7 elements are there or not. Is it 7?
No.
1, 2, 3, 4, 5, 6. So we have taken one more element. Okay, when we will just add both the number of element of A and B, then there will be a mistake, because we have taken this common element 4 while counting A. We have taken this common element 4 while counting B. That's why we have to subtract the common element, that is A intersection B. Number of element in A intersection B, that is one element, that we have to subtract from the total 4 plus 3 minus 1. When we will do, then and only then we will get 6 element. Are you getting it?
Yes.
That's why this rule is there, that when there is, in general, like when A and B are not disjoint set, there might be something common. Then the rule is this one: number of element in A union B is equals to number of element in A plus number of element in B minus intersection we have to subtract. Okay. Now the other rule is the same. Like if A, B are finite set, then number of element is A union B union C will be number of element in A plus number of element in B plus number of element in C. Now again we have to do the subtraction. So it will be minus number of element A intersection B. Why we are doing the subtraction? We have seen in the previous example. Minus number of element in B intersection C minus number of element in A intersection C plus number of element in A intersection B intersection C. So these are the 3 formulas. Now on the basis of this formula we will apply. We will be doing few questions. Let's do it. Just a second. Just a second. Yeah, practical problem on union and intersection. So the first problem can be, if X and Y are two sets such that X union Y has 50 elements. Here X has 28 elements and Y has 32 elements. Then how many elements does X intersection Y have? Let's do it. So here the question is saying that number of element in X union Y is already given, that is 50, right Lina?
Yes.
Where number of element in X is also given as 28. Number of element in Y is also given as 32. Then we have to find the number of element in X intersection Y, right?
Yes.
So we will be applying the previous formula. What the formula says, can you tell me? Number of element in X union Y is equals to what? Can you tell me?
Number of elements in X
Yeah,
plus number of elements in Y
yeah.
minus number of elements in X intersection Y.
Let's do it quickly. So here we are having 50 element, here we are having 28 element, here we are having 32 element, and we will get X intersection Y number of element. So what will be the answer after doing the calculation? Please do it and tell me the number of element in X intersection Y.
Uh, 10.
Perfect. So there are 10 element which is common in X and Y. Let's do the next problem. So in a school, there are 20 teachers who teach mathematics or physics. Of these, 12 teach mathematics and 4 teach both physics and mathematics. How many teach physics? Let's do it. So in a school, there are 20 teachers who teach mathematics or physics. Can you tell me what is already given in the question? Yeah, can you hear me?
Yes.
Yeah, what is already given in the question?
Elements of universal set.
Yeah, what?
Number of elements in universal set.
In universal set? That's what you said.
Yes.
Is what?
20.
Okay, number of element in universal set is 20. Then
Um, number of elements in another set is 12.
in mathematics, NM is 12. And
Number of elements is 4.
what you said?
Number of elements that teach both physics and mathematics is 4.
Yeah, both are 4. Here, how we will take the data? See, in a school, there are 20 teachers who teach mathematics or physics. Whenever this or is there, no, while doing the questions from sets like union, intersection, this or represent union. Or means either this one or that one. So this represent the union of both. Okay. So rather than writing the universal set, which is correct only, we will be writing the union of mathematics and physics is 20. Okay. Number of element in mathematics is 12, right? And both means common reason. So what's the common for, like in operation, common means intersection, right? Both means
Yes.
common. Who can teach mathematics also, physics also, both. That means common teacher. So that means number of element in M intersection P is equals to 4. Is it clear, Lina?
Yes.
So please understand, or will always represent union, both will always represent intersection. Okay. Or instead of both, if we will be having and, that will also represent intersection. So again we will be using the same formula, because here union, intersection both are there. So there is a formula which connect union and intersection both. So the formula is M union P is equals to number of element in M, number of element in P, minus number of element in and mathematics, intersection, physics, right? Let's put the data. So this is 20, this is 12. Here we are having number of element in physics we don't know, minus 4. Let's calculate. Tell me what will be the answer.
Four.
So 4.
Yes, 4.
So this 12 gone over there. So 20 minus 12 is 8, right? And then this 4 gone over there. So here it is negative 4. There it will be positive 4. Please check the calculation. Is it 4? Let's keep MP on this side only, because already it is positive. So let's
12.
what?
12.
12. Exactly. Let's do the next problem. So the next question is, in a class of 35 students, 24 like to play cricket, 24 like to play cricket, and 16 like to play football. Also, each student likes to play at least one of two games. How many students like to play both, okay, both cricket and football? Let's read it. So here it says in a class of 35 students, total 35 students are there. You can say that universal set, number of element in universal set is 35. But it also says I to play at least, see, at least one of the two games. So whoever is there, they are going to play. Okay. So here we can say number of element, like union of both the cricket and football players will be 35, because either they will play football or they will play cricket, or it can happen that they are playing both, right? And union covers everything. So we will be saying that union of cricket, union football, that is 35. Are you getting it? The first line, the first statement.
Yes.
Why we are not taking it as a universal set? Because you have seen that every element of the universal set can participate or cannot participate. They will be just sitting idle. But when we are talking about union, everyone is participating either in cricket or in football. So this is the case of either this or that, and we know or means union. So here it is representing the union of both the sets. Now 24, just a second. Just a second. No? Hi Atika, can you hear me? Okay. Hi Atika, can you hear me?
Hello, Miss. Good evening.
You are from class 9, right?
Yes.
So today for you, we will be discussing the concept, but it's from 8 p.m. IST, right?
Yes.
So still it's just 7:30.
Yeah.
Like after half an hour, you are having maths class, right?
Yes, yes.
Okay. So you can join after half an hour. Okay, so let's finish this one. Union between these two, we know Lina, that is 35. Here 24 like to play cricket, so 24 students are from cricket. 16 students are from football. And you see the last line, it says how many students like to play both. What is the meaning of this both, Lina?
Intersection.
Intersection. Or means union, both means intersection. So we have to find C intersection F, right?
Yes.
Let's do it. So number of elements union is equals to number of element in cricket plus number of players in football minus number of player like both the cricket and football. So here we are having 35 element. Here we are having 24 element. Here we are having 16 element, and we have to calculate the intersection. Please do it quickly.
Five.
What you got?
5.
5. Let's
Yeah.
check it. So if we will send this 24 to other side, it will be 35 minus 24. That is 1 and 1, 11. Here we are having 16 still, and here C intersection F. Now this 16 will also go over there if you will send the 16 also. So 11 minus 16 will be, yeah, it will be 5 only. Total 5 players are there, which will be there. Here we will get -5. Here also negative is there. Negative, negative will cancel out each other. Yeah, that's correct. Now the next one is, in a survey of 400 students in a school, 100 were listed as taking apple juice. 150 being as taking orange juice. And 75 were listed as taking both apple as well as orange juice. Find how many students were taking neither apple juice nor orange juice. Let's see what is given in the question. Then we will focus on what exactly the question is asking about. So here, if we will focus what exactly is given in the question. So see, in a survey, 400 students in a school, in a survey of 400 students in a school, 100 were listed as taking apple juice. So at first we know 100 we are taking as 100 we are listed as taking apple juice. So let's write it. Number of students who were taking apple juice, it's 100. Whatever you are just getting from the question, just write it at first, and then we will be thinking about the rest of the elements. All right. Here it
Okay.
says 150 as taking orange juice. So number of students who are taking orange juice is 150, and 75 were listed as taking both apple as well as orange juice. So both means what?
Intersection.
Intersection. Apple intersection orange. That is 75. Find how many students were taking neither apple nor orange juice. So this question is talking about there are people who are not taking any juice, who are not participating at all. What I said, union means everybody will participate, and universal set means there can be element which will be sitting idle. So here total 400 students are there, and the last line says find how many students were taking neither apple nor orange juice. That means fewer students are there who doesn't like any juice at all. So all the students are not taking the juice. Few students are there who are not taking any juice at all. All right. So here you can say the universal set is containing 400 element. Can you see it, Lina? In a survey
Yes.
of 400 students, that means the survey, we are doing the survey, or the survey is happening on overall student, that is 400. From the overall 400, let's keep it in a rectangular box. Total 400 students are there on which, like, on whom the survey is going on. On this 400 student, few of them likes apple juice, few of them likes orange juice, and few are there who doesn't like any juice at all. Okay, so let's find how many students are there who are having the juice, who just like juice, any juice. Apple, maybe it can be apple juice, it can be orange juice. How many students are there who are drinking the juice, who are choosing the juices? That means let's find the union first. Are you getting?
Yes.
Here we don't know union, and please don't say this 400 is the union, because 400 student the survey is going on this. After this survey, few are there who like apple, few are there who like orange, few are there who like both. Like, and union means everything, either apple or orange or both. So we will be finding the union at first. A union O, that we don't know out of 400. So number of element in A plus number of element in B, that means O, minus number of element in A intersection O. So in A we are having 100 element, in O we are having 150 element, minus 75. Can you tell me what we will get after the calculation?
Get 175.
We will get 175. So total 175 students are there who like either apple or orange. Here we have to find the number of student who doesn't like anyone. Okay, so let's write it in the operational form. So here find how many students were taking neither apple nor orange. So let's write it. Number of student who were taking neither apple, that means A complement, nor orange, that means O complement, and we have to find the intersection of both, neither apple nor orange. Can you see it?
Yes.
Let's see whether any De Morgan's theorem is there, which will help us or not. Let's get back to the upper step. So A intersection B we need to find. Like complement of A intersection complement of B. Yeah, here we got it. Complement of A intersection complement of B. Can you see this one? The rounded one. This is what we have to find, Lina, right?
Yes.
And union between both of them. Just a second. No? Just a second.